Lists have a special syntax when it comes to pattern matching, which is quite beautiful in its own way. In a later module, we will cover lists in more detail and deal with things like polymorphism and recursion. Our focus here in this module is to keep things simple so that you can focus on understanding the syntax of pattern matching with lists. And so, the examples we are going to use are intentionally contrived and simple. A list is made up of entries which are all of the same type. Say, for example, a list of int like this. Think for a second, how are you supposed to pattern match on this? Well, since a list is a collection of items, you could potentially have any combination of pattern matches. You might want to match the first item in the list to see if it is a 0. You might want to match the first 2 items in the list to see if they are 0 and 1, and so on. Let's say we want to write a function which will return the first int in a list of ints. So, for example, if the ints here were passed into the function, it would return the first item in the list, which is 0. We already know, because we saw in a previous module, that there is a function called head in the prelude which does this. And we also know that head is a partial function because when presented with an empty list, it blows up and does not work. We are going to define our own version of head and call it myHead to avoid the name clash with the function in the prelude that already exists. The function signature is defined so that it takes a list of int and returns an int. Now, we need to pattern match on specific cases to define the bindings for the myHead function. There are 2 definitive cases we can think of, the case where the list is empty and the case where the list is non-empty. Let's go ahead and define the case where the list is empty. There are 2 important things to notice here. The first is the pattern match which we are performing for the empty list. It is pretty much as you would expect. We use the raw empty list to represent itself when we want to pattern match on it as a value. The second important thing is the definition of the function body. We are calling the inbuilt error function and passing a string called empty list. The inbuilt error function is what causes the exception to be thrown when we pass the function an empty list. You can see that the exception that is thrown contains the same string we passed in. I'm doing this to match the behavior of the inbuilt head function for our example. Now, for the case where the list is not empty. To pattern match on lists which are not empty, we make use of the cons operator. The cons operator is depicted by a colon. Let's have a look at the rest of the definition for myHead, which uses the cons operator. When writing a pattern match for a non-empty list, you need to place it within brackets, like so. We then use the cons operator to destructure the list into the values which it contains. To the left of the cons operator is always an item in the list. Since this is a list of ints, we know that x will be an int. We are binding the value to the variable x, so it is available for us to use in the function body. To the right of the cons operator represents the rest of the list. Since it is a list of ints, the wildcard represents a list of ints. Remember, the point of the function is to return the first item in the list, which is what we do with x. For the rest of the list, we use the wildcard pattern since we don't care about its values. And when we call the myHead function with our list of ints, it returns the first item 0, just as we would expect. So, we already saw how we can pattern match to extract the first item in a list using our custom myHead function which we defined on a previous slide. Let's look at cons some more and see how we can use it to pattern match more than just one item in a list. Suppose we were now going to create another function called myToHead, which takes a list of int and returns a 2 tuple of the first 2 items in the list. How would we implement our pattern matching? Well, for the case where we have an empty list, it is the same as the myHead function. We just throw an error for the sake of simplicity. Now here is how we pattern match on the first 2 items in the list. Our pattern match can be read as x1 cons x2 cons the rest of the list. Remember, what is to the left of the cons is always going to be an item in the list, and so for x1 we know it is of type int. To the right of the cons is always the rest of the list, but if we look closely at the rest of the list, our pattern destructures that part too. To the left of the cons is always an item, and so we know that x2 is also an int. Then to the right of the cons is the rest of the list, which will have type list of int. We leave it as a wildcard match, which we do not bind to a name. The rest of the list could be any list of int, and remember, a possible value for a list of int is the empty list, and so the entire pattern of x1 cons x2 cons underscore will match lists which contain only 2 items and also match lists which contain more than 2 items. So you can see, for the whole pattern to match, the list needs to have 2 or more items in it. So let's see our function in action. If we call it with an empty list, we get our exception, as we would expect. If we call it with a list with many items, we get a 2 tuple back with the first 2 items in the list. Now if we call it with a list with only 1 item, we get an exception. This is because we have defined a partial function with no binding which matches. If you want, you can provide another binding for the case where there is only 1 item in the list. We have seen how to define a pattern match for a function which returns the first item in a list. And we've also seen how to define a pattern match for a function which returns a 2 tuple with the first 2 items in the list. Now, your task is to write the function binding and pattern match for the function my3head, which takes a list of ints and returns a tuple of the first 3 elements. Assume that the function only needs to deal with arguments of lists which have at least 3 items. So the list could be a list of 3 items or 4 or 5 and so on. And also do the same for the function called my4head, but this time return the first 4 items in the list. And assume that my4head only needs to deal with arguments of lists which have at least 4 items. Don't worry about defining the cases for the empty list or for when there are less than the required number of entries in the list. Just focus on the patterns when you return a value. Okay, pause the video and have a go. Let's start with my3head. Here is a binding for the function with a very specific pattern match. Let's read it together. So the first value in the list is bound to x1, and then we have cons, the rest of the list. The rest of the list is destructured into x2, cons x3, cons the empty list. This is a pattern which will match only on those lists with 3 items in them specifically. If you had a list with 4 or more items in this pattern, it would not match. Now let's look at another binding. Let's read this together. So, the first value in the list is bound to x1, then we have a cons, the rest of the list. The rest of the list is destructured into x2, cons x3, cons x's. Unlike the previous binding, I am not putting an empty list at the end, and unlike the previous examples, I've chosen to bind the rest of the list to the name xs, which is pronounced as x's, and is the usual convention in Haskell for the naming of the rest of the list. We don't actually use it in our function body, so it could be replaced with a wildcard underscore, but I've put it here to show some variety. And now, the code works as we expect, returning the first 3 items in any list where there are at least 3 items. Let's take a minute to do a deeper dive to properly understand how this works. Always remember that whatever is to the left of a cons is an individual item in a list, and whatever is to the right is the rest of the list. So we have x1, which is to the left of a cons, so we know for sure that if this pattern matches, there will be an item in the list, and since the type signature of the parameter is list of int, we know it will be an int. Then to the right of the cons is the rest of the list, but we continue destructuring the rest of the list by again using cons, so we have x2 cons the rest of the list. At this point we know for sure that there will be at least 2 items in the list for this pattern to match, x1 and x2. For the rest of the list we destructure it again to show x3 cons the empty list. So we know for sure that there can only be 3 items in this list for this pattern to match, x1, x2 and x3, because the rest of the list after x3 has to be empty. Now compare this with the other pattern. We have x1, cons x2, cons x3 just like before, but instead of the empty list at the end we have a variable named x's. X's here represents the rest of the list after the first 3 items, and since we do not put the empty list there, the variable name we have put, x's, will match for any possible list of ints. Remember, a possible list of ints is the empty list, so this actually matches that case too, and so we don't actually need the pattern with the empty list, because this one would have matched a 3-item list too. But I included it to show you how you would write a pattern match when you want to match a specific number of items in a list, versus how you would write it when you want to match a minimum number of items. Let's move on to defining my4head. Having done my3head, this should now be simple to understand. We are matching on a list formed of item y1, cons y2, cons y3, cons y4, cons y's, and returning a tuple of the first 4 items. Since x's was already used as a name, I've used the next letter in the alphabet and named the rest of the list y's. This is common in Haskell, and this works as you would expect it for the cases where there are 4 or more items in a list. And there we have it for pattern matching lists. as I hope you have come to appreciate. It is quite a beautiful and elegant notation once you have understood it. This video is a clip from a longer video for beginners starting with Haskell. Check that out if you would like to see all of the content. Also check out the entire Introduction to Functional Programming with Haskell course on the Learn channel. See you next time.